This is Susan Fox from the Faculty of Nursing at the University of Windsor with a series of short videos that demonstrate an approach to calculating medication dosages using dimensional analysis. One of the best things about this particular approach to calculating medications is that it doesn't require memorizing any formulas. Regardless of what type of medication or IV calculation you're doing, all you need to do is consistently apply two very simple concepts that you learned in grade school, math concepts that is. In the first video, I'll review these concepts and then I'll provide just two very simple examples of oral medications that show how these concepts are applied in the calculation of medication dosages. In subsequent videos, I'll step it up with a little bit more complicated medication problems that also use the very same and very simple concepts. So the first concept or principle of dimensional analysis that you need to apply when calculating medication dosages is the principle that any number or value divided by itself or by an equivalent value is equal to 1. So as a very simple example, we know that 4 divided by 4 is equal to 1. Similarly, using an algebraic variable or expression of x, we know that x divided by x is also equal to 1. And now using some calculations or some values that we might use in medication calculations, we know, for example, that 60 minutes divided by 1 hour, which is an equivalent value, is equal to 1. Because 60 minutes is basically equal to 1 hour, that's one number divided by itself, and that's equal to 1. So we can also similarly say that 1 hour over 60 minutes is also equal to 1. Again, because these are equivalent values, it doesn't matter whether you put the 60 minutes in the numerator or in the denominator because they're equivalent, and when you divide them by themselves, they're equal to 1. Another example is that we know that 1 gram is equal to 1,000 milligrams, and therefore 1 gram divided by 1,000 milligrams is equal to 1. And that is also equal to 1,000 milligrams over 1 gram, because it doesn't matter which one is on the top or which one is on the bottom. So the second concept or principle of dimensional analysis that you'll use in calculating medication dosages is that any number or value multiplied by 1 is equal to the original number or value. So using the same examples that we just used, we know that 4 times 1 is equal to the original value, which is equal to 4. Similarly, x times 1, that should be a multiplication sign, is equal to x, which again is the original value. We can also say then that 1 gram times 1 gram, or times 1, is equal to 1 gram, and similarly 60 minutes times 1 is equal to 60 minutes. So now in the next couple of slides, I'll provide two examples of how these concepts are used in the calculation of medication dosages. Suppose, for example, you have an order that requires that a patient be given Lasix 80 milligrams PO, and we go to the Pyxis or the medication supply, and we find that Lasix is supplied in 40 milligram tablets. So what you need to know is how many tablets do you need to administer. So here's what we know in this example. We know that in this situation, Lasix 40 milligrams is equal or equivalent to 1 tablet. So using the concepts that we talked about earlier in terms of 1, we also know that 40 milligrams divided by 1 tablet of Lasix is equal to 1, and that's also equal to 1 tablet over 40 milligrams. Again, because 40 milligrams and 1 tablet in this situation are equivalent values. So now we need to set up our equation to figure out how to answer this question. So what I do is I put an equal sign over toward the right, and I put over here what it is I want to give. I want to give tablets. So in the end, I need to know how many tabs I need to give. And I leave a little space here so that I can put my answer. Then on the far left, because I never know how much I'm going to have to calculate, how many times I'm going to have to multiply, I'm going to put the order over here. So what it is I need to give, I need to give 80 milligrams, and at this point, we always need to keep our units straight. So we always are using our units. So now I'm going to use the concept of multiplying by 1. So both of these values are equal to 1. So I can choose any one of these values, either one of these, and multiply it by 80 milligrams and end up with the value that I want to give, which is, it won't change the value. So, but what I want to do is I want to choose which one of those, this one or this one, that will cancel out units such that I'm left with the number of tablets that I need to give. So if I multiply by this one, for example, I'm going to multiply by 1 tablet over 40 milligrams. Note that I'm doing the straight line and I'm putting the number sort of one on top of the other, and I'm keeping my units straight. So I can see here that milligrams cancel and tabs are left on top. So I'm done with my calculation. I know that I have tabs on top and that's what I want to give, and there are no milligrams in my equation anymore. So now all I need to do is the math, and I can say that 80, there's no units now, times 1 tablet all over 40, no units, is equal to basically 80 times 1 over 40, and we know that the tabs are going to remain over there in the outcome, and that is equal to 2. So I'm going to give 2 tablets. Now supposing you didn't, oopsie, here, I'm going to erase, I'm going to try and erase all this, but it's not letting me. All right, let's just do it over here. Supposing you chose the wrong value, supposing you use that one. So we had tabs over here, and we started with 80 milligrams, and you mistakenly selected this one. I'm going to multiply by 40 milligrams over 1 tablet, because it is equal to 1, so you're not changing anything. It's still correct, but the problem is now your units are going to be milligrams squared over tabs, and that is not at all what you want, so you know automatically that you chose the wrong ratio. And so you would just switch it and try the other one. So let's do one more example. A little bit more difficult because you might not be able to do that one in your head. Okay, so we have an order of digoxin, 0.0625 milligrams PO, and digoxin comes in 0.125 milligrams per tablet, and the question is, how many tablets do you need to give? So again, we can start out with saying we know that in this situation, 0.125 milligrams is equal or equivalent to 1 tablet. And therefore, we can say that 0.125 milligrams over 1 tab is equal to 1 tab over 0.125 milligrams, both of which are equal to 1. So we can multiply by either one of those. We just want to choose the one that will help our units to work out the best. So again, the question is, how many tablets? So I'm going to put over here on the far right, tablets, put a little bit of space for my answer, put my equal sign, and over here I'm going to put my order, which is 0.0625 milligrams. And I'm going to multiply by 1 because I'm not changing anything if I multiply by 1. But again, let's look at the 2 options I have. I can choose either this one or this one, and to multiply because they're both equal to 1, but I want to choose the one that's going to get me the units that I want. Therefore, if I multiply by this one, which is exactly the same as the other one, as the other previous example, but they're not all like that. So in this case, I'm going to choose that value of 1, which is 1 tablet over 0.125 milligrams. And again, I see my milligrams cancel. I am now left with the units that I want. I want tabs on the top, which I have right here. I have no other units, and that's exactly what I want. So all I need to do now is the straight math of 0.625 milligrams divided by 0.125, and that, and then we can use the 1 there as well as if you want, but that works out to 0.5 tablets. So I give half a tablet. So I hope that is clear, and that it demonstrates to you how you can use how we use that concept of multiplying by 1 to deliver oral medications, particularly tablets. In subsequent videos, I'll step up the level of difficulty a little bit by using oral suspensions and perhaps injectable medications.